Okay, so welcome everybody to the Decrypting Tech Hype for the Busy Coder. I'm Stephen Chin. I run developer marketing at Oracle, and this is.
I'm Gerald Venzl. I'm a product manager at Oracle.
And so the reason they put us first in the conference, I have to thank Mateus for this. So we know that you're all busy coders, and you came to JFocus because you want to be smarter than the average coworker when you're hanging out at the water cooler. That's why you're here. But attending a whole conference for 2 days, that's way too much work.
Yeah, or be smarter than your boss, right?
Yeah, so you've come to the right talk. After this, you can leave. Don't tell the other speakers I told you that, because they're going to be upset at me now. But we're gonna cover a bunch of different technologies. We're gonna go through this really fast-paced, and hopefully you guys will learn a little bit about each of these technologies. If you have questions, feel free to ask them at the mic. That's what we've been told you guys should do. And I'm gonna kick it off with a bit.
Kick it off.
About cryptocurrency. Well, blockchain, but we're gonna first mention cryptocurrency. So this is what most people think of when they hear blockchain. So who in this room has some Bitcoins? Okay, very good. Now keep your hand up if you actually sold at the high. Yeah. Okay, so I just made a few targets. You guys will be asked for beers later. So as you can see, the high for cryptocurrency was crazy, and then it dropped right back down again. So this, a lot of this is based off of hype and people projecting like cryptocurrency is going to be used for, but then reality hits.
Did you ever own Bitcoin?
I mined Bitcoins. I mined some Bitcoins really early on, and I sold way off on the left side when it was worth nothing. Unfortunately, not good at technology, not good at business, and also really bad at energy consumption as well, as most cryptocurrencies are. So one of the problems in general with cryptocurrencies is that the way that they work is they have this large peer network of miners, which is how you actually make sure that it's a secure currency. But then as the currency becomes more and more popular, your power supply caused by all of the miners equals the value of the cryptocurrency. So there's this natural ebb and flow. As the value of the currency goes up, more people want to mine, more people are mining, you're consuming more electricity, and you get this inevitable crazy spike in the amount of energy. Good old-fashioned Visa, actually very efficient, energy-wise.
And you have to mention that those are U.S. households.
Yes, so this graph is millions of U.S. households consumed by our cryptocurrency. Bitcoin, very high usage. Ethereum, slightly lower usage, and they are working at ways where they can actually reduce the overall consumption of the network in power. But around the peak, it was consuming the same amount of power as the country of
the Czech Republic.
Yes. So quite a lot of currency consumed by cryptocurrency. But cryptocurrency is not actually what most of us need blockchain for. So it's interesting, but the typical use case for blockchain in an enterprise setting is using this core cryptographic technology for creating a distributed ledger and applying this to business problems. Right, so you can actually create private blockchains. There's a bunch of different use cases that this is quite useful for. The basic way that blockchain works is, you have a series of blocks where each block is constructed by taking a bunch of different transactions, putting it in a Merkle tree to get it down to a single hash value. You then hash that together with the previous block, a timestamp, a nonce, tack it on to the end of the blockchain, and then you have some way of arbitrating what the next block in the blockchain is. So with cryptocurrency, you have a lot of miners, and you can use that for the arbitration mechanism. And this is a basic comparison of public blockchain and private blockchain, and this gives you an idea why, as developers, we probably care more about private blockchain use case scenarios. So in a public blockchain, you have peer reconciliation by the majority. You have fairly long transaction times. So Bitcoin takes 7 transactions per second and can take up to 10 minutes to actually complete a full transaction end-to-end. Ethereum is somewhat faster, so 15 transactions per second and 15 seconds to completion. There's limited amount of data you can include in a transaction because everybody's storing the entire transaction history, so they have to constrain it in Bitcoin's case by the block size, which is 1 megabyte, Ethereum by a gas limit, so that kind of gives you a general processing limit on the network. And you can do smart contracts in Ethereum, and this is kind of limited by gas, but it's also somewhat limited what you can apply smart contracts for, and obviously no privacy if you're doing public blockchain. Private blockchain, and I'll talk about some of the different implementations of this, but you can choose your reconciliation strategy for what's the next major block in the network, who's invited to the blockchain. You can have much shorter transaction times, which will make it more suitable for some sort of fast data processing. You can use it for smart contracts, so you can use it for financial scenarios or other areas where you want to calculate things in network and have that be part of the transactions. And then, of course, you can have privacy within the network. So you can both choose what data is exposed and also which data you're exposing to other parties in the network, which is important for supply chain use cases and other cases you might want to use blockchain where you're using it in an enterprise setting. And the three probably most popular implementations that you'll see for blockchain used in different scenarios are Hyperledger Fabric. So this is an Apache project. It does consensus by doing it with pluggable consensus, so you can plug in your own consensus provider. You can also do smart contracts in your language of choice. You can do that in either Go or Java. And you have the opportunity to do cryptocurrency with chain code. So you can actually build cryptocurrency on top of this if you want to. This is used in a bunch of the different cloud providers. Our Oracle Blockchain Cloud Service is built on Hyperledger. R3 Core does used more in the financial industry. So this does by consensus by transaction level with notary nodes. It also supports smart contracts. You can implement those in Java or Kotlin as the languages you can use for it. Typically, you can also put legal prose and stuff in it. So this allows you to do more sort of financial type things. No possibility of building cryptocurrency on top of this. And the last one is Ethereum, which is becoming quite popular for a private blockchain as well. Besides being a cryptocurrency. So of course it supports cryptocurrency since it started as a cryptocurrency. Typically it's ledger level mining of proof work, and you do your smart contracts in Solidity, so kind of a custom language for doing smart contract work. So this is a little bit about the technologies, but the question is what use cases can you use this for? So if you're in any of these areas, financial services, legal, medical, IoT, there's probably a use case in your sector for blockchain. Anybody working in these industries by show of hands? Okay, quite a bit of folks. You're in the right session.
Can we do something cool with it as well?
Okay, so there's also potentially some cool stuff. So we did a project at for Oracle Code 1, which was blockchain beer.
So this is one of the first batches of
So this
beer
is the owner of the brewery we worked
off
together with,
of
Kyle.
The tanks that are equipped
Bozovic.
with the sensors.
And
we could track in
this is one of the suppliers that we
program
entered into
or
the
one
blockchain
data
network.
set,
So we had
the farmer,
a local
the
malting
field,
company.
when it was harvested, those field conditions.
That's the floor
whether
malts
it
in
was,
the back, so they
there
do
was
actual
lodging
floor
of the
malting
barley, or
of
whether
the,
what the temperature was that it was harvested
of the grains
at.
which go into the
even
beer.
things like what nitrogen you
And
put in the soil.
one of the nice things about
People are interested to know
blockchain
a
for a
little
use
bit
case like
more of the
this. So
story
basically, at
of
the
what went into
conference,
this beer.
you could scan a QR code, and these are the hop farm we went to. You could scan a QR code for the beer that you got, and it would show you the brewing conditions, which were entered into the blockchain by the brewer. It would show you the upstream suppliers, so the malting, the hops, and the yeast, which were all local suppliers. So they all entered into the blockchain transaction as individuals. And then as a customer, you could actually see this end-to-end information because all of those suppliers exposed information about where the beer was coming from, and then to the public, and then to each other, they can expose purchase orders and other transactions within the network. So this is a use case which we actually built on top of Oracle Intelligent Track and Trace with some local suppliers, but it helps small businesses to expose their product to you as an end consumer. So this is a nice way in boutique products to actually use blockchain as a way of exposing more folks to end user. But
And it's a nice way for you to actually know what's in your beer.
Exactly.
Right.
But there's also this really great technology which solves a very similar use case to this. And for everyone who doesn't need blockchain.
Yeah, so if you want to do something faster than 7 transactions per second and transactional, you might still want to look at this thing called a database.
Yeah, it's pretty good.
It's around for a while.
You know anything about databases, Gerald?
I know one red one, that's really nice. Sorry, was it the dolphin? I always get confused.
Okay, so now we're going to chat a little about chatbots.
Right, chatbots, another revolutionary technology that we only have since about 30 years or something, but we forgot about it. So who of you is actually dealing with chatbots and working on chatbots today? Okay, a few hands, great. So, you know, chatbots in its original form, you'll probably all have come across it at one point at a website where the annoying sales chat will pop up on the side, right? It's like, can I help you? Whatever, you look at the documentation or something, a thing pops up. And you're not really talking to a sales rep on the other end, you actually always were chatting to some sort of machine. Also in the good old days of what kind of web chats, if those things are even still around, you had some bots as well that helped you with a couple of different questions and answers. What actually made chatbots more interesting in the last couple of years is that we started integrating those into other technologies, mostly, or one very prominent use case being our mobile phone apps. So we tend to, thanks to smartphones, go from talking on mobile phones to texting each other again so that we can avoid talking to each other, which is great. And we have many, many different messaging applications. And businesses out there essentially want you to enable to just be like any other normal human being able to just text something and then basically the business takes over and executes something for you. So examples would be for like, you go, hey, I would like to buy 12 roses for my girlfriend, and you type this into Facebook Messenger, and actually there's a chatbot on the other end from a flower selling company, and basically goes, yep, okay, I can process this, I know what you mean, and basically order those roses and send them home and have all the information. Well, Facebook certainly has all the information of us anyway these days, as we found out, to send them home to your house, right? So that's quite nice because now you start actually using those technologies and text with machines on the other end for the intent of whatever you are after, whatever the business is after in selling you, just like if you were texting with your mates somewhere else, right? Of course, doesn't always go like this. This is sort of the very nice example where everything goes absolutely correct, and you know, a lot of times, frankly, chatbots do not quite understand what you want, right? And you end up with something more like this, where it's like just gone horribly, horribly wrong.
That's more like my conversations with my phone.
Fair. Actually, I always have those conversations with my wife. It's like never ever gone to anywhere close. The other thing that has evolved in the last couple of years is so we can now text with those chatbots, with those machines, and the other big nice thing is that we can actually start talking to them as well, right? So voice recognition has come a long way, and you probably all have one or more of those in your house. Now, who has one of those? Okay, so I'm always puzzled, right? I'm in IT. Those things will never ever show up in my house because I know exactly what's happening behind there. Anyway, right? So we can talk to them as well now, right? So this is another very nice way of actually interacting with machines. And it goes that far that there's actually companies out there that make those chatbots more appealing, give them more of a human form. Like you will see those Pepper robots, and forgot now where, but there's one bank that basically starts putting them in branches, and you actually start interacting.
SoftBank Robotics is the creator of the Pepper robot, and they started using them as point-of-sale devices to chat with people who come into the equivalent of a what's a big telecommunication here in Sweden?
Oh, you didn't do your research?
Telia. So imagine if you went to a Telia store and you had a robot come up to you and try to sell you cell service. That's what these guys do.
The robot chasing you along the way.
Exactly, but they're also good at something else.
They're also good at something else. So just as we saw with the chatbots that go horribly wrong when we text to them, that might happen there as well. But if everything goes completely wrong, you can still do one thing.
Check this out. Dance with me.
You can make them dance.
Okay.
Yay.
Well, let's go.
Yeah, this actually is better than talking to them.
So yeah, those were some of the SoftBank Pepper robots that we had at CodeOne as well last year, that you could actually walk up and talk to them. And for the biggest entertainment, I think it was certainly for me, was the dancing part.
Definitely.
Yeah.
Okay.
Right.
So we're going to chat a bit about serverless technology. So as we all discovered, this is part of the future. And it's not about throwing away your servers, as you guys know. It's about taking your servers and then moving them into like a large shared infrastructure where you're using cloud services. So traditional servers, you would buy these big monolithic servers up front, deploy big applications to them, scale by provisioning new servers, and then kind of based on where your data center is, that's the latency your customers get. So you're going to have the best latency to folks in your region. The dream with serverless is you only pay by the server time you use, right? You have these little functions, little micro-function architecture. The functions start up, they do some processing, they turn back off again, and then you get this automatic magical scaling in the cloud. So you get some large serverless cloud environment and a low latency by where it's coming from.
I know that we had some trend there years and years and years ago that promised the same thing.
Oh yeah.
Yeah, those big machines called mainframes that give you CPU cycles somewhere else. Anyway, we're digressing.
Yeah. So this is the problem when you get too old in the IT space.
You actually see the wheel turning around.
Exactly. So here's the ideal. So serverless, if you buy your servers, you have all this unutilized capacity, right? And then you're going to pay for that unutilized capacity until you fully use it, and then you're going to stand up a new server, and then you're going to always be paying more than what you have. So wouldn't it be more efficient if you could just follow that little black line into serverless nirvana and then save all this money, right? Okay, so this is a lie. This is kind of like one of Gil's lies. This is entirely wrong. And there's multiple things that are wrong with it, but the biggest one is the curve is at the wrong angle. So the cost curve actually is quite different for serverless. So it looks very cheap on the surface. You're paying by transaction, but you're paying by transaction, and you're also paying by gateway call in a lot of cases as well. So just to get in and out of the serverless environment, you have some sort of HTTP gateway fronting it, which you pay larger costs on, and then you get to the serverless environment, and you're paying cost per transaction. And if you look at what you're actually paying versus the real hardware costs, you're actually paying a substantial markup over it. So that's kind of the reality of serverless, but it still doesn't, there's other benefits to serverless like we talked about. So you're getting the scaling, you're getting the distributions, you're getting other benefits, and you're building on hopefully a nice architecture. So these are some of the serverless platforms that you might be building on top of. So AWS Lambdas is kind of, they pioneered this, mostly proprietary, so you're deploying and running your stuff on Amazon Cloud. Google Cloud Functions, so they also have an open source emulator, so you can run it locally, but it's not quite the same as what you're running in production. And the last one, Azure Functions, I think is of the three the most open. So actually, they allow you to run locally or in Docker images. They open source their whole stack. I think there's some different like analytics and performance stuff that's running on their own cloud version, which is not exactly the same as what you're running, but it's pretty open. But if you're looking for open, and I think this is one of the challenges with proprietary serverless, is you don't want to get locked in. So there's different ways to stay not locked in. One of them is to use an open source serverless platform. So you can actually build your technology stack on a serverless platform, which is open source by nature, and then you can run it on your cloud service of choice. And then cloud service providers can choose to support one or more open source serverless offerings, or you can just create your own Kubernetes cluster and deploy it yourself. So some examples of this are FN project. So this is an Oracle project. We acquired Iron.io and we open sourced their stack. OpenWhisk is by IBM. OpenFAS and Kubeless are both open source projects. So these are all great ways to run serverless on top of open source technology, and you can choose your own cloud. And the other thing you can do is there's also services which will allow you to deploy to different serverless environments, kind of like you create a common infrastructure and they adapt it to different serverless environments. So you get some portability as well. So there's different ways to achieve this, but I think one of the things we value as developers is kind of openness and freedom of choice, which is one of the things that's a battle with cloud providers, is they typically want to lock you in. And
I think, just shameless plug here, I think Sean has a talk later on serverless today.
Oh, yeah,
right?
Okay.
So call out for our colleague Sean.
He'll talk
Smith,
more about FN projects.
More about that.
So one of the things you can do with this, and in theory, is what I like to call own serverless. So if you're using an open source technology, you can spin up stuff quickly in the cloud, and then to a certain scale, this actually is more efficient, right? You can just deploy to cloud infrastructure, you get scale, you have an easy way of distributing geographically, and your costs are relatively low. And then when you hit that threshold where actually your bill is too high, then you can switch to deploying your own serverless infrastructure in a Kubernetes cluster on your own infrastructure, or whatever makes sense for your company's business. So this gives you a little bit more control, and then it lets you follow that nice red curve where you're getting kind of the best of both worlds.
And if you happen to have tons of old servers still in your data centers, you can use one of those open source technologies and deploy it on them as well.
So the top 5 reasons that you need serverless technology, because we all love new technologies.
It's probably my favorite.
Your sysadmin quit Friday. Time to switch. Anybody sign up for a cloud trial recently and get 1 million queries? Got to use it. It's free, right?
Before they expire, yeah.
Actually, the trick with this is, so once you get through the 1 million, which it actually turns into a wonderful revenue stream for companies like us. So you already are doing microservices, and it's not complex enough. So there's interesting projects being built on top of serverless environments to solve like pipelines and streaming of functions, because the next problem you get is you have all these little functions. How do you orchestrate them? How do you actually build architectures on top of it? So that in itself is producing a whole new software challenge. Okay, and top 5 is
4.
Oh, 4.
Oh, but actually,
this applies to me, yeah. Because I can't remember what number we're on. I have a very bad memory, I'll be honest, and so do my serverless functions. Okay, and the last one. Someone else is paying the bills, you just want to code, right? We all fall in this category.
Yep.
That's why we're here at JFocus, because we want to learn about the new technologies. We want our employer to let us use them on projects so we can pad our resumes. Okay, so a little bit about DevOps, Gerald.
Yes, sorry. Yes, DevOps. Going from technologies more into a cultural shift or trend, right? DevOps, like this great newish trend that creates even job titles and stuff, right? Like DevOps engineers and so forth out there. And certainly DevOps, when we look at it, has a very interesting history of where it comes from, right? So it's like Gregory has put this nicely in those little comics there. So before we had DevOps, we have had Dev and Ops, and we probably all know this, right? We probably still have this somewhere in our company, so deep in our hearts, where we just have this quick fix that we're going to produce, and all right, it compiles, and over the fence, off to the weekends. It's up for the ops guys to figure the rest out, right? It's like great. And obviously, not always does this go well and so forth, and we are off in the weekend, they have no clue what they're deploying and so forth, and sooner or later, our employers came to us and said to us all, right, and said, well, actually, the reason why we have an IT department is so that this stuff works, and not that you fight internal battles, and this is sort of where DevOps came from. Take the wall away, so that we're basically both screwed now, right? So, great new way of basically saying, well, it's not only you code it, compile it, and deliver, but you actually are also part of the delivery cycle. So ops and you should work hand in hand together. And of course, there's somewhat of a new trend appearing. This is the DevOps. It's like, yeah, we are working hand in hand together, and we found the next wall, which is the customer, right? It's like, great.
That's your best QA department.
It's like, absolutely, yeah. It's like, they will find everything. Yeah. But actually, so the essence of DevOps is working together in something like a continuous cycle, right? So rather than having those big chunks of releases and then shipping it over there and spinning it up on perhaps new hardware or environments and so forth, and then you don't know what's happening in production because you never tested on this and so forth. It should be more of a continuous cycle where development works with operations, right? So all the way from planning, and then we code it, and we do all the great stuff until testing, and then as said, we are actually part of the release cycle and the deployment, and actually responsible as well as the ops guys for operating this, and this in essence funnels into the next planning stage of the next development cycle or release cycle. And of course, one thing that this graph doesn't show is that Another thing that drives this behavior or has driven this behavior is that we want to shorten our release cycles. So rather than having the 5-year big releases where you don't even remember anymore what kind of new functionality comes in. You know, I live in the database land in Oracle. I know very well how 5-year releases feel. They're painful. You want to get this down to actually very small increments, right? As smallest as possible, right? So there's people out there, companies out there that deploy once every hour or even less, right? And because you do this, you actually have a very good feel of what you actually just deployed, right? It's like sometimes it could be just one commit, really, or just a couple of lines of code that you deploy, rather than a huge chunk of 5 years. And of course, doing this manually is very cumbersome. So this whole thing is, we tend to call the continuous delivery or the CI/CD pipeline, continuous integration, continuous deployment delivery pipeline. And there's certain tools out there that help you to do so. So like the pipeline looks a little bit like on this graph, right? So everybody, I think, uses some sort of source control versioning systems out there, right? So you would check in your code, you would have some build server that runs your tests and so forth, that deploys it, does some regression integration, stress tests and so forth. And then essentially the next step is to say, well, actually, and after this all passes, we deploy it automatically into production, right? And because we have all of this automated, it makes it very painless to go from we checked in a piece of code to deploying, which in the past was always much more cumbersome and sometimes painful. There's a couple of tools out there that you can use for this to actually create an infrastructure as code, so which essentially allows you to script the environment you want to test, deploy, etc. against. So I think 80% of the reasons why things fail in production is because the production environment or the development environment didn't mirror their production environment, the test environment didn't mirror their production environment, some kernel parameter that was set over there but not there and stuff like that. You all have lived through this, right, once. Infrastructure as code allows you to essentially make sure that the deployment is always the same. It's scripted and it will stand up an environment in a scripted fashion. And there's a couple of tools out there that you can use, whether it's Ansible, Terraform, Puppet, SaltStack, Chef, and actually, frankly, many others out there as well. And this is where you will have to help me out because I always forget the joke about this slide.
Yeah, well, that's the future, no ops. And actually, there's a running thread about this. So if you remember in the keynote, they were talking about, are we going to be replaced by machines? So you constantly have this refresh where like jobs get taken away as things get more automated. And so at the Cloud Native Compute Foundation meetings, they were actually talking about it's not really no ops, it's diff ops. So your ops people are getting different types of jobs, doing like analytics and monitoring and making sure that the new ways of deploying and new ways of supporting stuff actually work in a production setting. So we still have jobs and the ops people still have jobs. It's all
you know
good.
the job that never goes away?
Yeah.
Those guys that take spreadsheets out of email just to tinker around and send it out again in emails. Like that, spreadsheets and emails.
Yeah, Excel
Anyway.
is the bane of anybody who wants to do real work. Okay, so last topic we're going to cover a little bit about machine learning and AI. So this is the future of technology. At a really high level, the way you're using this sort of technology is you're taking a bunch of inputs, using some sort of framework which pushes it through a bunch of different hidden layers, and then an output, and you're using some sort of either reinforcement training or some way of having the computer model over time adapt and evolve and actually understand more about the human world than we do. So one of the projects I think which gets a lot of press and news is the DeepMind project at Google. So they're doing AI algorithms which play Go, play chess. Anyone hear of their latest little adventure? AlphaStar. Okay, very good. So AlphaStar is their new venture where they actually beat up a bunch of pro StarCraft players with a AI trained in Protoss versus Protoss matches. So if anyone's a StarCraft fan out there, you're wasting your time. Computers have already figured out how to beat us in just about everything. Go back to programming because we'll get a few more years out of that. There's a bunch of frameworks out there which you can use to take advantage of these technologies. TensorFlow by Google, Caffe, Microsoft CNTK, MXNet, Torch, DL4J, which is a Java deep learning library. There's a whole plethora of these. They're useful for different sort of domains and problem spaces. So there's kind of a large tool chest you need to actually apply to this. And eventually, we're going to reach a point where the computers are actually smarter than us. So I think it's already happening. You can see the accelerating rate of computational power in the world versus human intellect is not looking too good in the future.
I actually think that slide is wrong.
Why? Why? I mean, it's just a projection. I mean,
you know, with Trump, Brexit, and all the other stuff going on, you would think that the human intelligence is actually on a race to the bottom right now.
Okay, so I modeled that as a flat curve, but you could be right about this. But there's a few conditions that we need to reach the singularity, and I just broke it down to 3 really simple ones. So the first one's data.
Right.
So we need enough data to model and simulate the entire world, right? So we're close. There's 7.2 billion nucleotides in a human body, or 7.2 billion humans, 6.2 billion nucleotides, 1 times 10 to the 19th total DNA in humans. And then the digital world has 5 times 10 to the 21st bytes in 2014. So we can already model all of us. So that's a good start. And the Earth has 1.325 times 10 to the 37th data. So we're probably not that far off at the rate of data growth, where we can actually model the entire physical world in the computer space. So the next thing we need is exponential rate of technology growth. So we already see this happening with, specifically computers designed for machine learning problems, like the tensor processing units. Tesla's working on specialized machine learning chips. So there's a bunch of efforts going in this direction. And the other space, which is getting a lot of exploration, and there's some good sessions here at JFocus about this, is quantum computing, because that offers an entire new way of doing things in massively parallel and solving NP-complete problems, which previously were computationally impossible to solve. So I think computers are getting there. But the last thing is, you can't, this is all in the virtual space. Computers need to build computers. So this also is happening. So this right here is a 3D printer, which is 95% printed by a 3D printer, and it can print the parts for itself. So it's basically a self-replicating robot.
It's like it's only the head that is not.
Yeah, the hot ends that currently can't be printed in plastic. So there's little bits of it which can't be printed, but that's where they gather and they harvest the parts from the rest of us, the robots.
We could throw a Matrix joke in there actually for next.
So you can see where this is going, right? And I think all of this has been predicted.
I think this has been predicted a long time ago.
A long time ago, they actually predicted the coming. And let's take a quick look at that.
In the 21st century, a weapon will be invented like no other. This weapon will be powerful, versatile, and indestructible. It can't be reasoned with. It can't be bargained with. It will feel no pity, no remorse, no pain, no fear. It will have only one purpose: to return to the present and prevent the future. This weapon will be called the Terminator.
Okay, so there you have it. It's all been predicted.
Hollywood already knew it in the 80s, I think.
And I think he already destroyed California. He took out, bam, Schwarzenegger.
Well, he certainly took out the Oracle office in the last movie.
Okay, so thank you guys for coming to our presentation about emerging technologies. You can find out more about what we're doing with developers and our cloud technologies at developer.oracle.com. Gerald and I will be around the conference, hanging out.
Also, if you want to play with some of the technology, the booth staff told me to advertise to come to the booth. We have some mini labs that you can go through.
We're giving out photon chips. So you get free embedded chips that we're going to program and will help you get set up. So we did those in the workshop yesterday, but or no, stand up. This guy's the hardware genius.
And we also have candy there. Apparently, I was told that the Swedish folks.
Why didn't they
eat
bring
the
it to our
most candy.
session?
Well,
that's
because
not
we're not
nice.
Swedish, I guess.
Oh.
I was told something like 18 kilos a year that the Swedish eats on average in candies. Anyway.
Okay. So thank you guys very much. The obligatory don't trust us slide.
And if there's any more questions, please feel free to ask.
Feel free to come up and ask us questions in the front of the room. We'll be happy to answer it. So thank you guys.
Thank you.